different of a setup. So what we're going to see in this situation is distributive property. And distributive property is going to come from when we have situations where there is more than one person. And then people are based off of another person. So that may sound a little weird right now, but I'll give you an example. So let's say we have person one and they are called Jamie. So I'm going to write J for Jamie. We know nothing about Jamie. So Jamie is going to be considered X because we know nothing about them. But there's another person named Anne, and we know that Anne is 5 more than Jamie. So if Anne is 5 more than Jamie, Jamie, add 5 more to that, will represent Anne. So you see that we have more than one person. Okay, now, a lot of times this will happen. We will see either they say their sum is maybe 50. So we would say their sum x plus 5 equals 50. So we don't see distributive property with that. This kind of looks like our consecutive integers problems, right? We just add the two together, Jamie plus Anne. But what we're going to see today is that sometimes it'll say that Anne is 2 times 5 more than Jamie. So 2 times 5 more than Jamie, all of a sudden we have distribution. So we're going to start seeing a little bit more of these complex word phrases to describe someone, right? 2 times, so 2 times 5 more than Jamie. So add 5 to Jamie times 2. And then our problem will start to look like this, where we have distribution. So that's where these can feel a little bit complicated. But how we always start the problem is by making a list of the people. You guys can see that here. And that helps you kind of sort out your information. So let's look at an actual example. Aaron and Alice are bowling. Alice's score is twice. So we see that multiplication. Twice means 2. 2 times the difference of Aaron and 5. Difference is subtraction. So that's going to look like a little bit like this. So we're talking about Alice. Alice is 2 times the difference. Now the difference means subtraction, right? So 2 times the difference of Aaron's score and 5. Well, do we know Aaron's score at all? That is a no, which means Aaron will be our variable. So X and 5. So this is our representation of Alice, 2 times X minus 5. And then now we need a representation of Aaron. Now, when we were trying to figure out Alice, we said that we didn't know Aaron's score, right? We were unaware of it. We didn't know it, so we called it X. And we want to remember that because for Aaron, he's literally X, right? So we're just going to make an X for Aaron, and then 2 times X minus 5 is Alice. So now it's saying their sum of their scores is 320. So remember, is means equals. That's how we know we have an equation. So the sum, Aaron plus Alice equals 320. So now I'm just going to add their scores together. Aaron is an X plus Alice, which is 2 times X minus 5 equals 320. And now I'm going to start solving, and we're just using the same properties of do I distribute, do I clean up, and so forth. So do I have to distribute? Yes. So I bring down the X plus 2X minus 10 equals 320. Now I need to combine like terms. X and 2X makes 3X. And now I begin isolating, so I'm going to add 10 to both sides. So I get 3x equals 330. And then divide by 3, and I get x equals 110. Now, just like yesterday, x isn't our final answer. X represents Aaron, right? So Aaron is 110. But what does that make Alice? Well, what we can do, if we know we have x is 110, we can substitute in for Alice. So 2 times 110 minus 5. And then I solve 110 minus 5, that gives me 105. 2 times 105 is 210. So Alice is 210 and Aaron is 110. And we can double check. 110, 210, that adds to 320. Okay. So let's look at another one. Mari, Carlos, and Amanda. So we have 3 people, so we've gone ahead and labeled. So Mari, Carlos, and Amanda collect stamps. Carlos, so we're going to talk about Carlos first, has 5 more stamps than Mari. Okay, so 5 more than is a turnaround phrase. More means plus. So Carlos has 5 more than Mari, so M plus 5. I'm going to use M just to remind myself that is Mari. Amanda has 3 times as many stamps as Carlos. So this is Carlos, right? M plus 5. Amanda has 3 times that. So this is where we see our parentheses, 3 times Carlos. Well, Carlos is M plus 5, so we have to multiply the whole thing by 3. And then the last thing we have is Mari. We don't have that listed, and there's no more information, but what did we already call Mari? We called her M, so Mari is just M. Now, it says altogether. Altogether means addition or the sum. So altogether, Mari plus Carlos plus Amanda has 100 stamps. So now I'm going to substitute in the 3 different expressions. So Mari was just M plus Carlos, which was M plus 5, plus Amanda, which was our big one, 3 times M plus 5 equals 100. Now that I have my expression Mari, Carlos, Amanda, I'm going to solve, and first I need to distribute. So I have 3M plus 15, and then I bring down everything else, M plus the M plus 5. Combine like terms, so I have M, M, and 3M, so that's 3, 4, 5, 5M, and then 5 and 15 is going to add to 20. Now I'm going to isolate. So I subtract 20 from both sides. So I have 5M equals 80. And then I need to divide by 5. So M equals 16. So M stands for Mari. So Mari has 16 stamps. Carlos has M plus 5, so 16 plus 5, right? So that's going to give me 21. And Amanda has 3 times Carlos. Well, Carlos was 21, right? So 3 times 21 is 63. All right, so last one. This is going to be a little bit different. Instead of people, we're talking about a garden. It says a rectangular garden is fenced in on all sides with 256 feet of fencing. The garden is 8 feet longer than it is wide. So 8 feet longer, right? The garden is, that's the length. Longer is length, so that's what we're talking about here. So 8 feet longer than it is wide. So it's the width plus 8. Then the width is just going to be W because we already defined as W, so width plus 8. And now we want to solve for the length and width of the garden. Okay, so what we're talking about here is fencing, 256 feet of fencing. Fencing is the outside. So that is going to be solving for perimeter, right? That's what we have to figure out. So the perimeter, the fencing is 256, which means I have length plus width plus length times width. So 4 sides, and then the sides again, right, to make up 4 equals 256. I'm going to combine like terms. So I have 4W plus 16 So 4W equals 240 when you subtract 16, divide by 4, I get W equals 60. So the width is 60. And that means the length is 60 plus 8, so 68. All right, so for variables on both sides, this is the last bit. I'm just going to do 2 problems here and leave the rest for class. So variables on both sides, that is when we are comparing 2 options. So you may see something like this is company A better than company B. And we're going to set them equal and see which one would provide the best situation for us. So we're going to have 2 different things we're talking about. We're going to set them equal to compare. So for example, Brittany has job offers from 2 companies. One company, so we'll call this company A, is a starting salary of $28,000 plus or with a raise of $3,000 each year. Each year, remember that means multiplication. So let's go ahead and start out writing about company A. It's a starting salary of $28,000 plus $3,000 per year. The other company, which is company B, has a starting salary of $36,000. So it starts off better, but it's only an increase of a raise of $2,000 each year. So better start, worse increase. Bad start, better increase. How many years will it take for the companies to be the same? Same is where it's equal. That's why we're putting the equal sign between them. We want to see how many years it will take. So first we have variables on both sides. We need to get rid of one. So I'm going to subtract 2,000y. So that gives me 28,000 plus 1,000y equals 36,000. Now I'm going to subtract the 28,000 to begin isolating the variable. So 36,000 minus 28 is going to give us 8,000. And then if you divide by 1,000, we just have y equals 8. So in 8 years, they will pay, because we're talking about payment, right? The same. And that's it. So these are a lot easier just because we're comparing and it's a little bit less work to set up the problem. We're just comparing 2 things and then setting them equal. So next one, a moving company. So we'll just start the first one. This is A, charges $800 plus $16 per hour. So to show up, you have to pay $800 and then $16 per hour of work. Another moving company, so we'll call this B, is $720, so cheaper to start, plus 21 per hour. Write an equation to model the situation. Determine how many hours it will take for it to be the same rate. So company A, company B, see when they're equal. So same story, we have variables on both sides. Get rid of one, I always say the smaller. 800 equals 720 plus 5h. Start isolating the variable. So we have 80 equals 5h. Divide by 5, so we get h equals 16. So in 16 hours, they will cost the same. Okay, that is where we will stop today. We'll do the rest 4 problems tomorrow.